padlock attachment on a DIN rail-mounted circuit breaker can indeed serve as an acceptable disconnecting means for a group of small single-phase motors powered by the circuit breaker. The fundamental principle behind any disconnecting means is to provide a reliable and safe method to isolate electrical equipment from its power source. This isolation is essential for performing maintenance, repairs, or any other work that requires the equipment to be de-energized. The National Electrical Code, or NEC, outlines the requirements for disconnecting means in Article 430, which specifically addresses motors, motor circuits, and controllers. While the NEC doesn't explicitly detail every single type of acceptable disconnecting means, it does establish general guidelines that must be followed. Firstly, the disconnecting means must be readily accessible. This means that it should be located in a place where it can be easily reached and operated without the need to climb over obstacles or move other equipment. This accessibility ensures that in an emergency, the power can be quickly shut off to the motors. Secondly, the disconnecting means must be capable of being locked in the open or off position. This lockout/tagout, or LOTO, capability is crucial for safety. It prevents the accidental re-energization of the motors while someone is working on them. The padlock attachment on the DIN rail-mounted circuit breaker fulfills this requirement as it allows the circuit breaker to be locked in the off position, ensuring that the motors remain de-energized. Thirdly, the disconnecting means must have an ampere rating not less than 115% of the full load current rating of the motor. This ensures that the disconnecting means can safely handle the normal operating current of the motors without overheating or failing. For a group of small single-phase motors, the total full load current must be calculated to determine the appropriate ampere rating for the circuit breaker serving as the disconnecting means. Fourthly, the disconnecting means must clearly indicate whether it is in the open or closed position. This indication helps prevent confusion and ensures that workers can easily verify whether the motors are de-energized. The handle of the circuit breaker typically provides this visual indication. Fifthly, the disconnecting means must disconnect all ungrounded conductors of the circuit. In the case of a single-phase motor circuit, this means that both the hot and neutral conductors must be disconnected simultaneously. The circuit breaker accomplishes this by interrupting the current flow in both conductors when it is switched off. Sixthly, the disconnecting means must be suitable for the voltage and current it is intended to handle. Circuit breakers are rated for specific voltage and current levels, and it is essential to ensure that the circuit breaker used as the disconnecting means is properly rated for the voltage and current of the motor circuit. Several other considerations are important when using a padlock attachment on a DIN rail-mounted circuit breaker as a disconnecting means. Firstly, the padlock and attachment must be robust and durable enough to withstand the environmental conditions in which they are installed. This includes factors such as temperature, humidity, and exposure to chemicals or other corrosive substances. Secondly, the padlock must be of a high quality to prevent it from being easily tampered with or broken. Thirdly, a lockout-tagout procedures must be followed diligently. This includes properly identifying the circuit breaker being locked out, attaching a tag to the padlock indicating who locked it out and why, and verifying that the motors are indeed energized before starting any work. In some cases, depending on the specific application and local electrical codes, it may be necessary to install a separate disconnecting means specifically for the motors. This may be required if the circuit breaker is located in a remote location or if it is not readily accessible. However, if the circuit breaker meets all of the requirements outlined above and is properly installed and maintained, it can serve as an acceptable disconnecting means for a group of small single-phase motors. It's crucial to consult the relevant sections of the NEC, specifically Article 430 and any applicable local electrical codes to ensure compliance with all requirements. A qualified electrician should always be involved in the design, installation, and maintenance of electrical systems to ensure safety and compliance. Let's delve deeper into the specific aspects that make a padlock attachment on a DIN rail-mounted circuit breaker an acceptable disconnecting means, focusing on the practical application and safety considerations. Firstly, the selection of the circuit breaker itself is paramount. It should be a circuit breaker that is specifically designed and rated for motor applications. These circuit breakers, often referred to as motor-rated circuit breakers, have characteristics that allow them to handle the high inrush currents that motors draw when they start up. Standard circuit breakers make trip unnecessarily due to these inrush currents, leading to nuisance tripping and potential downtime. The motor-rated circuit breaker has a time delay feature that allows it to ride through these temporary overloads without tripping. Secondly, the DIN rail mounting system provides a convenient and organized way to mount the circuit breaker. DIN rails are standardized mounting rails that are widely used in industrial and commercial electrical installations. They allow for easy installation and removal of components, making maintenance and troubleshooting simpler. The circuit breaker should be securely mounted on the DIN rail to prevent it from vibrating loose or becoming dislodged. Thirdly, the padlock attachment must be specifically designed for use with the circuit breaker. These attachments typically consist of a metal bracket that fits over the circuit breaker handle and has a hole for inserting a padlock. The attachment should be made of a durable material that can withstand the forces applied when the padlock is locked and unlocked. It should also be designed in such a way that it prevents the circuit breaker handle from being moved to the on position when the padlock is in place. Fourthly, the padlock itself should be a high-quality industrial padlock that is specifically designed for lockout/tagout applications. These padlocks are typically made of steel or aluminum and have a unique key or combination. They should be resistant to tampering and corrosion, and they should be clearly labeled with the name of the person who locked out the circuit breaker and the date it was locked out. Fifthly, the lockout/tagout procedure must be followed meticulously. This involves several steps. Firstly, the circuit breaker must be switched to the off position. Secondly, the padlock attachment must be installed on the circuit breaker handle. Thirdly, the padlock must be inserted into the attachment and locked. Fourthly, a tag must be attached to the padlock indicating who locked out the circuit breaker and why. Fifthly, the person who locked out the circuit breaker must retain the key or combination to the padlock. Sixthly, before starting any work on the motors, it is essential to verify that they are indeed energized. This can be done using a voltmeter or other appropriate testing equipment. Sixthly, it's also crucial to consider the environment in which the circuit breaker and padlock attachment are installed. If the environment is harsh or corrosive, it may be necessary to use special materials or coatings to protect the equipment from damage. For example, stainless steel enclosures and corrosion-resistant padlocks may be necessary in coastal areas or in industrial facilities where chemicals are used. Seventhly, regular inspections and maintenance of the circuit breaker, padlock attachment, and padlocks are essential to ensure that they are in good working order. This includes checking for signs of wear or damage, lubricating moving parts, and testing the circuit breaker to ensure that it trips properly under overload conditions. Any damaged or worn components should be replaced immediately. Eighthly, proper training for all personnel who may be involved in lockout/tagout procedures is critical. This training should cover the proper procedures for locking out and tagging out equipment, the hazards associated with working on energized equipment, and the importance of following all safety regulations. Refresher training should be provided periodically to ensure that personnel remain up to date on the latest procedures and best practices. Ninthly, it is important to document the lockout/tagout procedures and to keep accurate records of all lockout/tagout activities. This documentation should include a list of all equipment that requires lockout/tagout, the procedures for locking out and tagging out each piece of equipment, and a record of all lockout/tagout incidents. This documentation can be used to track trends, identify areas for improvement, and to ensure compliance with safety regulations. Tenthly, remember that the NEC provides minimum safety standards. Local codes may have additional or more stringent requirements. Always consult with a qualified electrician or electrical engineer to ensure that the electrical system meets all applicable requirements. In conclusion, using a padlock attachment on a DIN rail-mounted circuit breaker as a disconnecting means for a group of small single-phase motors is acceptable, provided that all of the requirements outlined above are met. The circuit breaker must be properly rated. The padlock attachment must be specifically designed for use with the circuit breaker. The padlock must be a high-quality industrial padlock The lockout/tagout procedure must be followed meticulously, and the equipment must be regularly inspected and maintained. Proper training and documentation are also essential to ensure safety and compliance. Always consult with a qualified electrician or electrical engineer to ensure that the electrical system meets all applicable requirements. By following these guidelines, you can ensure that the motors can be safely isolated for maintenance or repair.